Alright guys, so here are the next set of notes for ballistics. This one is going to be on how forensic scientists actually study bullets to make the comparison between the bullet and the gun that was fired from in hopes to catch a suspect. So the first part of these notes are going to be the bullet characterization guide. The second set of notes we are going to talk about cartridges. All right. So for those of you that know a ton about bullets, please know that we are not diving all the way down the rabbit hole. We are just going to be talking about the surface information that you would need to know as a forensic firearms examiner. All right. So let's get moving. Okay, so the first thing that a forensic scientist is going to be looking at is going to be rifling. Now, rifling happens as the bullet is leaving the gun, right? And there are two different types of rifling that you might particularly would see on a bullet. We have polygonal rifling, and then we have cut rifling. If you take a look at the actual marks on the bullet, if you look, the polygonal has smooth transitions between what we call lands and grooves. So the grooves are going to be the indented part, and then the lands are going to be the raised part of the marking. So polygonal here looks a little bit smoother. If you take a look at the cut, you can see a very distinct line between the lands and grooves, and we call those shoulders. Okay, so that would be considered cut rifling. Now, in terms of the lands and grooves, as a forensic scientist, you are going to count them, right? It's going to be part of your identification of that particular bullet to a gun. So normally how this works is we find a bullet at a crime scene, and then we find the suspected weapon. The firearms investigator will actually do a test fire of the same type of bullet that was found at the scene, and then they will compare the marks between their test fire and the one that was at the crime scene. So this is one of the characteristics they're going to look at. And if you take a look at this picture over here, I just placed a blue dot here because sometimes what they'll do is use some sort of felt tip marker or somewhere to let them know when they started counting, so they make sure that the number is accurate. So if we start here, we are going to be counting the grooves. This is the first groove, second groove, third groove, and you would go all the way around the bullet until you get back to wherever you placed your mark, and that would be considered the amount of lands and grooves for that particular bullet. The other thing is going to be the direction of the twist. There are obviously two different twists. You have a left twist over here, and if you take a look, the rifling is slanting toward the left. And over here, we have a right twist, where the rifling is slanting toward the right. That one's pretty self-explanatory. Now, we're also going to measure the bullet. So we're going to use an instrument called a caliper, which is in this picture right here, that is going to be used to measure bullets. They also use calipers to measure different body parts and things like that. Back in the day, they had all these measurement tools for doing that kind of measurement. The one that's important for bullets is going to be, first one is going to be measuring of the lands and grooves, the ones that you just counted. So you're going to figure out, you're going to calculate the millimeter length of the lands and grooves. And then the other one is going to be, you're going to measure the width of the bullet. So reading a caliper is a little bit difficult. So these numbers on top are going to be the whole numbers. And then these numbers here are going to be the decimals. So if you take a look, wherever the 0 lines up, that's where you're going to take your whole number from. So the 0 lines up at about 11. It's one tick past 10. And then you're going to take a look and find out which one of these lines is lined up perfectly with a line above. So for example, if I were to take a look at the 1, it looks like it's off center, so it's not lined up perfectly with that line. Go to the 2. Nah, the 2 is in the middle of here. If we go to the 3 is almost there, but not quite. The 4 is even closer, but if you take a look at 5, it is almost dead center in the middle of this line above it. So if I were the forensic examiner doing this measurement, I would say that the width of this bullet is 11.55 millimeters. All right. The other thing that the forensic investigator is going to do is they are going to take the weight of the bullet. So just to make our lives more complicated, they have actually created a unit for bullets. So we are going to weigh our bullet in grams, and then we will convert it to grains. So the conversion factor for that is 1 gram equals 15.43 grains. So I just put a quick example down here. It's a really quick conversion, kind of like when you're doing your BAC conversions from pounds to grams. So we have 12 grams. You want your grams to cancel out, so obviously that's going to be in the denominator, and then it's 15.43 grains. So to find this answer, you're going to take 12, you're going to multiply it by 15.43, and that is going to give you the answer of 185.16 grains. All right, it's just another common comparison tool. The more things that you compare, the more let's just say individualized your identification is. Okay, so here's the big one. I'm sure a lot of you guys know a ton of bullets, but I wanted to show you just the chart of the 6 top bullets that are usually used, and I'm just going to do a brief description, and we're not going to talk about all the different, oh, that's a 38 special, or that's a 44 mat. Look, we're not going to talk about that right now, because you really don't need to go into that much detail. But I want you to know some of the basics about the bullets. So I'm going to start with the wad cutter. The wad cutter is right up here in this picture, and it usually has some sort of flat front, and it's usually very cylindrical in shape. Usually it's designed for competitive shooting, so when you are shooting at a paper target or something like that, you want to have as clean a definition of your bullet hitting whatever surface it's supposed to, so that when they go to look at it or measure it and compare it to somebody else's, it is very clear about where your bullet hit on, say, a target or something like that. So typically they are used for that. I mean, you could use another bullet, but say if you were to use like a full metal jacket, full metal jackets create like a huge disturbance on a paper target, and it might be hard to determine where exactly that bullet is. The next one is going to be our full metal jacket. They call it a full metal jacket because it's going to be a lead bullet, but it's going to be encased in some sort of harder metal. Typically it's copper, and in this picture you have this full metal jacket is definitely a copper bullet. And then we move on to the jacketed hollow points. So big things about hollow points. Some experts say that they provide more accuracy, but if you look, it actually has a hollow point, hence why it gets its name. When we talk about jacketed hollow points are designed to, let's just say, collapse when they hit their target. And the reason why a lot of people tend to use them is because they have a tendency to not create through and throughs, meaning that the bullet doesn't go in the body and out the other side. And here's the deal, with a full metal jacket, there's a lot of velocity behind that bullet. And if you are, let's just say you're shooting at a target, if you shoot a full metal jacket at a target, potentially it could go through the target and then through whatever else is behind it. Okay, hollow points are designed to collapse, right, to prevent it from going through a target and hitting something that you obviously didn't mean to hit. When we talk about jacketed soft points, there are a huge variety of these types of bullets. They are commonly marketed as hunting rounds, and they are definitely more common for rifles than pistols. Then the next is going to be a lead round nose. These bullets are going to be great for a multi-purpose use. The problem is that they're cheaper, and guess what? They are made of lead, which isn't awesome. Okay, but they do feed well into a variety of weapons. They do deform on impact, and they are, according to experts, extremely accurate. When we talk about the round nose is going to offer you more penetration than a flat nose would, and that's why they seem to be the more popular of the style. Now, in terms of the wad cutter versus the semi-wad cutter down here at the bottom, obviously they look a little different, right? So they have a shorter bearing surface, which if you look at the wad cutter, it's more cylindrical. The semi-wad cutter tends to have a distinct, let's just say, rounded points. The good thing about the semi-wad cutter is many of them have like grease-filled grooves on the side. So they are safer to fire at higher velocities, and they seem to be more effective for self-defense and big game hunting. All right, so that is the end of the bullet side of the notes. Now we are going to move on to the cartridge side of the notes. So